Okay, I'm going to cover method overloading. This basically allows us to have more than one method with exactly the same name. So typically we use this when we want to do the same thing, but we want to do it with a different type of data. Okay, so we've actually been doing this since the start. If we use system.out.println, we can provide it with a string, but we can also provide it with other different data types. You can see this if we have a project and we type system.out.println. You can see we can provide it with no parameters, in which case it will just print out an empty line, but we can provide it with what we normally quite often use, a string, potentially though a float, an integer, some kind of object, or an array of characters. So these are different overloads that we can pass the println method, and the way that we're able to do this is simply by declaring more than one of the same method. So if we were to have a look at println, say, let's go to implementation, you'll see in Java there are quite a lot of different methods, all entitled println, but they have a different parameter type. Not only that, but we can vary the number of parameters. Again, we've done this if we wanted to convert an integer into a string. If we provide one parameter, it takes the default behavior of using base 10 to do that. But if we pass in the second parameter, we can, as a radix in this case, so we're saying, use hexadecimal, it will convert that integer to a string, but in base 16. Okay. We've actually done something similar if you've created more than one constructor for a class. Essentially that's a bit like an overloaded method. You've got multiple constructors with different parameter types. So there we go, demo method with the same name but different parameters. So what might we do? Let's create static void. We'll create a method to just display a greeting. So we might say greet string name, and we'll print out the name with hello in front of it. Similarly, we could create another method that would also print a greeting, but this time we might want to print their title, name and surname. So we could do like string title, string name. In fact, that'll do. Don't need to surname. It still gives the same idea. In this case, we might system.out.println hello. There we go. So if we wanted to use that from here, we could say greet Andrew, and you can see it lights up instead of calling this method with this parameter. Similarly, we could say greet Mr. Andrew Muncie, and you'll notice that because we're passing in literals, IntelliJ IDEA is just giving us the parameter names here so we can see what we're doing. Obviously, if we run that, we'll get outputs of both. There we go. I've clearly missed a space here, so just pay a bit more attention. Okay. This generally is great, but it can be a bit problematic if we are calling methods where we have a subtype, okay, of two types. So it will normally call the appropriate overloaded method for the subtype, but there are some occasions when it won't, depending on how things are declared. So let's do a quick worked example of that. Let's create ourselves a couple of classes. We will create a let's go with a home appliance class. Okay. Okay, and then let's create another class. We're actually not going to do very much with those classes. We're going to say, we'll call it a kettle. And that kettle is going to extend the home appliance class. Okay, now normally we'd have some logic inside kettle, and normally we'd probably have some logic inside home appliance. For what we're doing today, it's not particularly important because I'm actually going to write a method in main that is going to do something differently depending on the type of thing that we pass it. So let's just get rid of our existing code and go back to having an empty project. Let's create a method that's just going to describe any given class. So I'm going to call this describe, and we'll have one that describes a home appliance. And all this is going to do is print out this is a home appliance, whatever I can spell. And I'll also have one that takes a kettle. And it will print this is a kettle. Okay. So if we create a home appliance, and we call our describe method, and we pass in our appliance, we'll get a description of this is a home appliance. Let's run that and see it happen. Similarly, if we create a kettle, let's just comment that out for now. Now, obviously a kettle is a home appliance, but in this instance we are declaring it as a kettle, so we'll call our describe kettle method. If we run that, we can see that happen. Okay. Now, one thing we can also do in Java, okay, is to describe something as its parent, or instantiate something as the type of its parent class. Okay. Now, if we do that, we lose function or the ability to call directly the functionality that belongs to kettle. So let's just add a method to kettle. We'll have a public void boil. Okay. So normally with our kettle, we could do kettle.boil as expected. But we can declare it as a home appliance because a kettle is a home appliance. If we do that, however, we lose access to kettle.boil because we're only able to treat it as its parent class. Okay. When we do that, however, Java understands the type of kettle to be of this kettle, which is a kettle, to be a home appliance, and therefore when we call describe, it will call the method in the home appliance class because it treats it as a home appliance. If we run that now, there we go, this is a home appliance. It's not factually incorrect because a kettle is a home appliance, but it is something to be worthwhile being aware of. That leads me on to the final point, which is if we have things in a collection, which we're likely to do. So in this case I've got animal and dog extends animal, but if I put them in a list of animals, which I have to do if I want to put the this bird, which is an animal, and the dog in the same list, it is going to call the method for the type of the list. So we can do the same with our appliances. We could say array list of home appliances. Let's just import array list. And if we said appliances.add, and we could add our appliance, which I'll comment back in, just get rid of the describe method. And we'll move our kettle up here. We'll not describe kettle anymore. And we'll also add our kettle to our appliances. Then we can say we can create a fast fast enumeration loop, so we can say for appliance, appliance. In fact, I've called it appliance here, so what we probably want to do, one, make the home appliance, let's call this sum appliance, so we're not using the same name here, in appliances, and we can call describe and pass in sum appliance. And what it will do is, because it's an array list of home appliances, despite the fact that this is a kettle, even if I declare it as a kettle, it's going to treat them all as home appliances. So this is declared as a kettle, kettle is added to an array list of home appliances. In the same way we lost our ability to boil our kettle before, if I try and use sum appliance, I can't call boil because all it knows is it's a home appliance. And again, if I run this, we're going to get a home appliance. Okay. You might then wonder, well, how would we get around this problem? Well, you could instead decide that the ability to describe an appliance actually belongs to the appliance itself. Okay, so if we make home appliance have a describe method, and print out, you wouldn't normally print out inside a class like this, but just for demo purposes we'll do it. This is an appliance, and then we could go into our kettle and we could override the describe method. In this case we probably wouldn't want to call super describe because that will print out appliance. Instead we'll print out this is a kettle. So we've got a describe method in both classes and a more bespoke method in our kettle class. And so what we're likely to do here, instead of calling a method that takes the overloaded method with overloads, instead of doing that, we'll call sum appliance dot describe, and we should get that behavior back because it is intelligent enough to call the method that belongs to whatever class it is. So it will call the one that belongs to kettle when we get there. So we run that. That there solves our problem.